So, hello, welcome back to Bonds. This is going to be Bonds Part 2. So, let me write that down, I guess, first. Bonds Part 2. What we're going to do here is we're really going to focus on Chapter 16, which is in the investment management textbook. What we're going to focus on is managing bond portfolios, understanding the sensitivity of bonds and what impacts bond values. So let's talk about that. What are the three main things, or what are the main variables that impact bonds? The first is going to be interest rates. We've seen before that when interest rates change, bond values change. When interest rates go up, bond values go down. When interest rates go down, bond values increase. Okay, so interest rates. And so I'm going to translate that into this term yield. So bond yields. When bond yields go up, values go down. When interest rates go down, value goes up. Another has to do with the maturity structure of the bonds. Bonds that have a long time remaining until they mature are more sensitive. We saw that before, are more sensitive than bonds that are short term, that have a short time period remaining until they mature. So we've got interest rates or yields, we've got maturity, and we also have coupon rates. Coupon rates. Give me just a moment here. There we go. Cash flow. What's true about bonds is that bonds with low coupon rates tend to be more sensitive to interest rate changes than bonds with high interest rates. We talked about zero coupon bonds before. A zero coupon bond obviously has zero interest that it pays. And zeros are a lot more price sensitive on a percentage price change basis than are coupon paying bonds. There is a term called bond duration, which takes all of these main three variables into effect. Bond duration. And it's kind of an ugly looking formula. Scary perhaps, but it's not that bad. 1 plus y over y minus 1 plus y plus t times c minus y over c times 1 plus y raised to the t power minus 1 plus y. Just notice our formula here. We've got yields, that's the y, we've got maturity, that's time, and then we've got coupon rate. So this one measure called bond duration actually takes into account all those three variables and gives us one measure that we can use to determine how sensitive a bond is going to be to interest rate changes. The greater the bond duration, the greater the sensitivity the bond is price-wise when interest rates change. Okay, so how can we use that? Well, if we thought interest rates were going to go up, we know values go down. And so once we learned a little bit more about duration, we can say, oh, then we would perhaps want to decrease the duration of our portfolio. Again, interest rates go up, value goes down. So if we can shorten the duration of our portfolio, then it will make the bond portfolios a lot less price sensitive when interest rates do in fact rise. If on the other hand we thought that rates were getting ready to drop, we know that there's a positive price effect, and so we might consider increasing the duration of our bond portfolio, because then when rates go down we would get a bigger price increase because the duration would have been higher. Alright, so I'm going to give us a problem here to work. I'm going to run through it here. You write down or grab this formula, copy it to this next area here. Alright, and so here are our inputs. Let's take a bond that has 30 years until it matures. This bond has a coupon rate of 6.5%. It has a yield, so this bond is currently priced to yield 7.5. Well, what that tells me, since interest rates are higher than the coupon rate, interest rates go up, value goes down. This bond is going to be selling at a discount. We'll solve for that actually. All right. So we've got a 30-year bond, 6.5% coupon. It's currently priced to yield 7.5%. Let's assume, like all of our other bonds, we're going to assume that it has $1,000 par value. So let's plug in our inputs here. We're going to say future value is equal to 1,000. N is equal to 30. Our interest rate is 7.5 because we're pricing this bond in a 7.5% rate environment. The coupon rate is 6.5%. So remember, that means the bond is paying 6.5% interest per year. So that's going to be $65. So let me plug that in to my calculator. And oops, 65 is payment. Solve for PV. And I get $881.90. All right. So this bond is currently selling, or currently worth, the intrinsic value is $881.90. Now I'm going to come over to this other formula, our duration formula, and we're going to calculate the duration. And so we start here with, again, there's only three variables that go into this formula: yield to maturity, time to maturity, and coupon rate. So we'll enter everything here, our interest rates, in decimal form. So this is going to be 1 plus the yield. So that's going to be 1.075 divided by 0.075 minus 1.075 plus T, so that's the number of periods. There's 30 years till the bond matures. Coupon rate 6%, or rather 6.5, minus the yield, which is 7.5. Coupon rate 6.5 again, so 0.065. 1 plus the yield is 1.075, but that's raised to the 30th power minus 1 plus 0.075. Alright, let's do it in stages. 1.075 divided by 0.075. This gives me 14.33 minus, let's do the numerator. Okay, I'm going to start over with the 6.5 over here. So I'll take 0.065 minus 0.075, and I'll multiply that times 30, and then I'll add 1.075. So in the numerator, all that comes to 0.775. Alright, so just as a reminder, what I did was I focused on the parentheses first, 6.5% minus 7.5, so that gave me negative 0.01, I believe. Multiply that times 30, and then added 1.075. Now in the denominator, I'm going to take 1.075 and raise it to the 30th power. 1.075 to the 30th power. And I get a number, and then I'll subtract 1, which is what it tells me to do, and then it tells me to multiply it times 0.065, and I do that, and then it tells me to add 0.075. So here I get 0.579072, long number there. This gives me 14.33 minus 1.33 approximately, which is gives me a duration measure of 13, and it's in fact 13 years. Okay, so the duration of this bond is 13 years. Lots of different interpretations to that, but again, it is an important number. All right. One interpretation of duration is a payback. It's a time-weighted payback. How long does it take us, if we buy this bond, how long does it take us to get paid back? It's a weighted average payback more specifically, but in a weighted average format, how long does it take us to get paid all of our future cash flows? That's really what it is, right? So anyway, our duration here is 13 years. Right? Now, kind of a real interesting thing happens with duration. Right? So we've just determined the duration of this bond is 13 years. So I'm going to draw a long timeline here. 1, 2, 3, 4. I'm not going to write them all out. 12, 13. All the way out here, here's 14, 29, 30. All right? So here's our timeline for this bond. We know that this bond is paying a coupon rate of 6.5%. So it's paying $65 a year. 65, 65, 65. Right? All these are $65 cash flows. And then in addition to this last 65, if you're the owner of the bond, you're going to receive $1,000 when this bond matures. Right? Everybody's probably good with this. This is just the cash flows with this bond. Right? Well, there's an interesting thing that happens at the point of duration. And so this particular bond, if you remember, has a duration of 13 years. So here's what happens. Let's assume that you own this bond. And every year that you are owning this bond, every year you're reinvesting these $65 cash flows that you get. Every year you're reinvesting these cash flows. Okay, you're not going out and buying pizza every time you get a $65 check. You're not spending it, you're reinvesting it. And the idea here, this bond, if you remember, the yield on this bond is 7.5%. You bought this bond for $881.90 perhaps. That's what we came up with a minute ago. But the assumption is that you're reinvesting all of these cash flows every time you get them, and you're earning 7.5%. Okay, and so if that's the case, let's see how much money you will have accumulated at year 13. You would have received a $65 payment. You would have gotten 13 of those. You would have invested them at 7.5%. So let's see what that's going to have grown to. I'm going to plug in just what I've got here. 65 is the payment, 13 is in, 7.5 is I. Solve for future value. So essentially you've got the future value of annuity, 1352.36 approximately. All right. So you should have 1352.36 at year 13. I hope you followed that. You've taken each one of these $65 checks and cash flows that you got, you reinvested it at 7.5%, because remember, in this example, the yield to maturity is 7.5%. Okay, now, once you get to year 13, then you've got this pot of money right here. You could also sell your bond, couldn't you? Because this bond still has 17 more years on it. And so if you wanted to sell your bond at this stage, you could. Let's solve for the present value of this bond. If we assume interest rates are still at 7.5%, then you should be able to sell your bond. And this is what the inputs would be. This bond, whoever buys it, is going to receive $65 every period. They're going to receive $1,000 when the bond matures. There are 17 more years, because it was originally 30 years, wasn't it? And 13 years have gone by, so there's only 17 more years. Let's assume the interest rate remains at 7.5%. Let's see what your bond should be worth. I hope you're following that, because when you get to year 13, you can sell your bond, and whoever buys it is going to buy it based upon all of the remaining cash flows. There's 17 more years worth of cash flows. So what we're doing is determining the present value of those. And I get, I'm doing it, that can't be right. Let's try it one more time. 65 is my payment. 1,000 is future. 17 is N. 7.5 is I. Solve for PV. And this time I get something that makes sense. 905.66. 905.66. All right. So at this stage, at year 13, you should have potentially two pots of money. You've got the 1,352 that you've been reinvesting. So let me do that. 1,352.36. Plus you can sell your bond, and it looks like the rate, the price will be 905.66. I'm going to add those two numbers together, and you've got 2258.02. Now what's the significance? Well, here's the significance. If interest rates don't stay at 7.5, what if interest rates drop from 7.5 to 7? Okay, well, think about what's going to happen. Two things are going to happen. If interest rates drop from 7.5 to 7, this number that we see right here, 1352, is going to be smaller. It's not going to be 1352. Because if interest rates drop to 7%, you're not going to reinvest your cash flows at that 7.5% rate. So it's going to be less than 1352. However, if you discount these cash flows to solve for the bond at 7%, that is, if we discount the cash flows at 7 instead of 7.5, it's not going to be 905, it's going to be higher, because when interest rates go down, value goes up. All right? So if rates go down, we know this number is going to be less, this number is going to be more, but it's still going to add up to 2258. Okay, it'll still add up to 2258. If on the other hand, interest rates had not gone down but had gone up, maybe this went to 8%. Well, this number is going to be higher. But if it goes to 8%, this number is going to be lower. But it's still going to add up to 2258. This phenomenon where your reinvestment rate risk, that's the risk that the rates, your reinvested cash flows are going to be different. Your reinvestment rate risk and the interest rate risk, that's the risk that your bond price is going to change, offset at the point of duration. So any change in your reinvested cash flows because interest rates change will be exactly offset by the change in price. So you have a known outcome. Interest rates can go up, they can go down, they can go all around, and you're still going to have 2258 at year 13. This only happens, for this example, this only happens at year 13. It would not happen at year 10. It won't happen at year 14 or 16 or 20. It happens at year 13 because the duration of this bond is 13. All right. That's why we refer to this concept that I've just described here is immunization. This is an immunization example. You know what it means to be immunized, right? You could go get a flu shot because you don't want to get the flu. You don't want to feel the effects of the flu. And so you get a flu shot. You get immunized. Well, here, what we're trying to avoid is that our bond portfolio feels the effects of interest rate changes. And so we're able to immunize our portfolio here. If you had, for instance, a known obligation 13 years from now, you owe exactly, let's say, $2,258. this bond that we have here will pay for that. It will immunize that obligation. You don't have to worry about, oh no, I may not have enough money if interest rates change. No, you'll have exactly enough money, because interest rate risk and reinvestment rate risk offset one another. Right? So I know this is a more complicated discussion than we started with in Bonds Part 1, isn't it? Bonds Part 1 was just calculating values and yield to maturity, yield to call, zero coupon bonds. I think we also talked about the current yields, right? And so now we're in the management side, portfolio management side. And that's why duration's a pretty important concept in bond portfolio management, because we are trying to manage the effects of interest rates. Just like with stocks, remember, we're trying to manage our market risk, our systematic risk. We want to build a portfolio that will have sensitivity to the market that we're comfortable with. Well, that's kind of what we're doing here with our bond portfolios, making sure we understand the different variables that can impact our bond portfolio. Right? Alright, so now what I want to do is show you another application of duration. Let me see what I had over here. Alright, I'm going to grab this just so we'll be familiar. Copy. And remember, our duration that we have just solved for, I'll write it over here. We solved for duration. And it was 13 years. All right. Okay, so now let me show you another application of duration. Okay. I'm going to take duration and I'm going to divide it by 1 plus my yield to maturity. And that gives me another term called modified duration. And modified duration is kind of a cool tool also, because here's the relationship. Here's what modified duration does for us. If we want to estimate how much a bond is going to change in value when interest rates change, we can use modified duration. I mean, we already know if interest rates go down, value is going to go up. Interest rates go up, value is going to go down. But how much will it go up, or how much will it go down? That's what modified duration is going to help us understand. So I'm going to put our estimated percentage price change in a bond is equal to -1 times modified duration times the change in interest rates. All right. -1 times modified duration times the change in interest rates. Right? Now, you actually have this on page 521. I think you're going to appreciate how I've written it here, because I have written it different than your textbook did. So let me write how your textbook did it. It's the same thing, but I'm going to put delta P over P, which is the change in price over price. So that's percentage price change, equals -D times the change in 1 plus Y over 1 plus Y. Believe it or not, these two things say the same thing. Because right here I have modified duration. Well, if you remember some of your, and I've got a -1. So let's start there. There's a -1. Alright, and then my formula here says modified duration, which we've said is equal to, it's called Macaulay duration, divided by 1 plus the yield. Macaulay, named after Frederick Macaulay. You don't need to know that, but it's Macaulay duration. I think the Macaulay family might appreciate it. But if you look at this, there's modified duration. There's D over 1 plus Y. And then I have simply the change in interest rates. Their formula says the change in 1 plus the interest rates, but it's still going to be the same because the ones will cancel out. All right. So what we're going to do here, and I think it's going to be a pretty good little exercise. Okay. So we're going to come back to well, I tell you what, let's just do it here. All right. So let's go ahead and use this formula. I want to estimate what the price change is going to be for this bond if we assume that interest rates go from 7.5 to 7 and from 7.5 to 8. Okay. So the first thing, let's assume that the yield is now equal to 7%. So the yield, remember, on our bond was 7.5. So now I'm going to assume that interest rates go down by 0.5%. Let's use our formula that I've just written here. -1 times modified duration. Okay, so if you would, bear with me. I should have done this before. You see up here at the top where I've got modified duration is D over 1 plus Y. So down here then, modified duration on our bond before any price change is 13 divided by 1.075. 1.075. This gives me 12.093. So our bond that we've been working with over on the left, $1,000 par value, 30 years till it matures, 6.5% coupon. It's currently priced to yield 7.5%. We know it's worth $881.90. We also know we solved for duration. It was 13 years. And we also know then that modified duration is equal to 12.093 because that's what modified duration is. It's Macaulay duration divided by 1 plus the yield. So now what we're going to do is say, all right, what if yields change to 7%? Well, our modified duration is 12.093. We don't change that because the yield changed. We'll take the yield change over here in the change in interest rates. So we got -1 times modified duration times the change in interest rates. Well, the interest rates went down 0.005. Okay, it did. It went from, if you don't believe me, say it went from now it's 0.07. Subtract what it was, 0.075, and you'll see that's -0.005. It's not 0.05, that would be 5%. So this is 1/2 of 1%, and it's important that we get the two negative signs because negative times negative is a positive. And when interest rates go down, value goes up. So I'm going to take my 12.093 times 0.005, and I get 0.0605. So my estimated bond price is going to be 6% higher. It had been $881.90 right here, but now I'm going to add a little about 1.0605 to it to see what it's worth, and I get $935.22. So what we've just done is use duration. We didn't have to use time value of money, PV, FV, anything like that. We just used duration to estimate what the price was going to be if interest rates dropped from 7.5 to 7. Let's try the other one. What if we said the yield doesn't go down but in fact goes up to 8%? Well, let's plug it in again. -1 times modified duration times the change in yield. This time the yield went up. So it's going to be positive 0.005. It went up 0.5%. Alright. And so this is going to be the same outcome, isn't it? Except it's going to be negative 0.0605. So our bond had been worth $881.90. Now it's going to be 1 minus 0.0605. And I get, that can't be right. Let's try it again. Well, maybe it is. Let's try it again. 881, 881.9. I'm sorry, give me just a minute. 12.093.005 times, okay, 1 minus 881.9 times, okay, that's better. That's going to give me $828 point about 0.58. 828.58. I kept coming up with a really like 870 or something. So 828.58 is what I come up with. So let me show you here what this looks like on a graph. I'm going to draw this blue diagonal line here. I'm going to put price on this axis, and I'm going to put yield on this axis. And let's start with our original bond. Our original bond was price to yield 7.5%, and we said that the bond was worth $881.90. So what we're doing here with modified duration, that's what this line is. This line is we're using modified duration to estimate the price change. We said if interest rates go from 7.5% to 8%, we just said it should go to 828.58. And we said if interest rates went from 7.5% to 7%, we said the bond would go up, and we estimated that, I believe, I have to go back and look, we estimated that it would be 935.22. 935.22. So modified duration, our -1 times modified duration times the change in interest rates. Pretty effective, huh? I mean, it shows us the inverse relationship between price and yield. When interest rates went up, value went down. When interest rates went down, value went up. Now I want us to do I know this may be hard to follow, but it's really important, and I think it's somewhat interesting here. So let's go back to our original bond. I'll write it over here again. Originally we said the future value of this bond was $1,000. The payment on this bond was $65. N was equal to 30. Interest rate we said was 7.5. And I said let's solve for PV, and we got 881.90. Alright, now I'm going to just get it in my calculator one more time and confirm that. 65 is payment, 30 is in, 7.5i, solve for PV, and I do in fact get 881.90. Alright, now what I'm going to do here for a second, I'm going to change the interest rate to 7. in my calculator, that's all I'm going to do is hit 7 my interest rate and then solve for PV. And I get 937.95. I'm also going to plug in, okay, what if interest rates were at 8? And I'll solve for present value. And I get 831.13. Now, let's compare these numbers, which are the actual numbers. This is actually what's going to happen if interest rates go to 7. This is actually what's going to happen if interest rates go to 8. So you can see we're close, but we're off a little bit. If interest rates go down to 7%, this bond's actually going to go up to 937.95. So we're off a little bit. We're off, I don't know, let's see, almost $3, right? Or $2.73, I think might be, but still a pretty good guesstimate, still pretty good. How about if interest rates go up to 8%? Well, we had estimated it was going to be 828. We can actually see it's only going to be 831, so it falls inside here, 831 something. So when interest rates do go up, the bond is going to drop, but not as far as we anticipated it would. So what I want you to see here, and this is an important thing, is that the actual relationship between prices and interest rates is not a straight line. It's not linear. It's curved. The actual relationship between price and yield is not linear. It is curved. More specifically, it's convex. Your textbook talks about bond convexity. Okay? And you can see it here because it's not linear. I hope you can see, though, that convexity is a good thing for us, because when interest rates go down, we know value is going to go up, but the more convex the bond is, the more the bond would go up in value if the bond was even more convex than the red line, right? Or if interest rates go up, value goes down. The more convex the bond would be, if the bond was that convex, you could see it would go down less. So see, convexity is our friend. Convexity works in our favor both ways. When interest rates go down, the more convex it is, it goes up more. When interest rates go up, and we know that's not a good thing for our bond prices, when interest rates go up, value goes down, but the more convex it is, it's not going to fall as far. Okay, so that's a feature, and it's important that you understand convexity. So what are the variables that affect both duration and convexity? Well, here they are: yield to maturity, time to maturity, and coupon rate. Remember, those are the three variables that were in our formula for duration. So I'm going to write down the word duration here, and I'm also going to write down the word convexity next to it. And you need to know whether these variables, these three variables, are inversely related or directly related. When I say inverse, that means opposite, right? I mean, for instance, I'll give you an example. Yield to maturity, inverse. I'm going to write this kind of funny. I'm going to write I inverse. I'm going to write the IN in one color, and I'll show you why, because I'm going to try to help you remember, and not that you have to remember it, but I'm going to help you anyway. Okay, of these three variables over here, two of them are expressed as interest rates. Right, so I'm going to write the interest rate variables are inversely related to duration and convexity. The interest rate variables are inversely related to duration and convexity. So low yielding bonds have greater duration. Low yielding bonds have greater convexity. Low coupon bonds have greater duration. Low coupon bonds have greater convexity. Time is directly related. That means long-term bonds have greater duration. Long-term bonds have greater convexity. Short-term bonds, shorter duration and less convexity. Crazy, huh? I know, lots going on with this stuff. Great chapter. Now, I do want to point out one other thing here. And we talked about, I believe, in Bond Part 1, the idea of a callable bond. Okay, a callable bond. Not all bonds are callable. But if you purchase a callable bond, that means the company has the right to call the bond early. And they might do that if interest rates have fallen. It's very similar to people who refinance their homes whenever interest rates fall. I've done that a few times in my career. Interest rates drop, I find cheaper money for my house. And so I borrow whatever the balance is on my home that I owe, I borrow that from a new bank. And I pay a lower interest rate, and then I pay off the higher interest rate loan. Companies like to do that as well. That's why they might issue a callable bond. And so if interest rates start to drop, then it increases the likelihood that the bond is going to be called. So it actually might lose value instead of gain value. All right, so we just drew a typical bond, right? A typical bond might look like this. That wasn't very good. Let's try that. Let's try that second part again. All right, so here is a bond with typical convexity. When interest rates go up, value goes down. When interest rates go down, value goes up. All right, but when we have a callable bond, and I'm just drawing this line here to help me. I don't have to keep that line here. Okay. If interest rates go up, well, yeah, the callable bond has regular convexity. But when interest rates go down, yeah, it might originally start to increase because that becomes attractive, because when interest rates go down, value goes up. But the further the interest rates fall, the more likely it is that the bond is going to be called. So what we see on the right hand side is a callable bond has two parts to it. Okay, it's got right here, it's got what, I don't know if we'd call it regular. Let's see what your book calls it. Regular convexity. They call it positive convexity. Okay, I should have known, because I do happen to know for sure that this is called negative convexity. This is called negative convexity. Right? And so if we have a bond that's callable, just recognize it's going to have, it's just, you can't evaluate it the same that you do a non-callable bond. Certainly if interest rates go up, I don't think there's any difference between a callable and a non-callable. When interest rates go up, value goes down. Okay? But when interest rates go down, value typically goes up, and it will initially for both bonds, but at some point, if interest rates keep dropping, the callable bond becomes less valuable, because whoever buys it knows that you're not going to get to hold this bond very long, because the company's probably going to call it. So there's another form of duration, another type of duration, and it's called effective duration. So we've talked about Macaulay duration, we've talked about modified duration, and now I'm going to ask you to just understand a little bit about effective duration. Your textbook has a really good example on effective duration. But just recognize that there is an adjustment that's made for bonds like this callable bond that has what's called an option in it, an embedded option. So we have to make an adjustment to our typical approach to understanding duration. I'm not going to ask you to calculate it because I'm not going to do it for you. There's this very simple, easy example to follow on page 529, 530. I just want you to recognize the term and understand basically what effective duration is doing. It's a comparison. It looks and says what's the percentage price change if interest rates go up and if interest rates go down. You've got a good example of immunization in your textbook, but I've already provided you an example of immunization. The last thing I wanted to really hit, because I know I don't want to kill you with this chapter here in the last week, but I wanted to talk about some, it's on page 543. There's some active bond management. There's some bond swaps. Okay. Well, you know what it is. What a swap is. A swap is when you swap one thing for another, right? And so there are what do we have? I think 4 different swaps I was going to mention real quick. The first one is called a substitution swap. This is based upon the idea that maybe you're a bond portfolio manager and you have a bond in your portfolio that maybe you think is overvalued. It might be a good time to sell it, but you like having that bond in your portfolio. But you look out and you see in the market another bond with very similar characteristics that's not worth as much. Your book gives an example, I think, of Toyota and Honda. So maybe you have a Toyota bond in your portfolio, okay, and it's well priced, but there's a Honda bond out there, different company, that has very, very similar characteristics, same industry, that maybe is undervalued or correctly priced. You sell the one in your portfolio that you think is overpriced, and you buy one out there that you think is underpriced. Right? You can make some money. If you sell one in your, you sell something that's in your portfolio to buy something that's cheaper outside your portfolio that's pretty much the same bond, that's a substitution swap. The second discussion or swap that they talk about is called the intermarket spread swap. So there's different bond classes, there's different bond categories. You got government bonds, you've got corporate bonds, and then within the corporate bonds you've got AAA, AA, A, triple B, on down into junk bonds. And so the intermarket spread swap is when the yield spread between two of the bond sectors, maybe government bonds and AAA rated bonds. Okay, if you think the spread has varied from what it traditionally is, there may be an opportunity to make money, right? Your book says when an investor believes the yield spread between two sectors is temporarily out of line. They say, for instance, if the current spread between corporate bonds and government bonds is too wide based upon its historical trends, what's probably going to happen is the spread is going to narrow. It's going to revert back to its mean. And so a intermarket spread swap would be one where you try to go ahead and make a trade because you recognize there's something amiss in the markets. So you go ahead and make a trade. Maybe you buy corporate bonds now knowing that the spread's going to narrow again. The third one is called the rate anticipation swap. So, and this one is simply saying that if you think interest rates are going to go up, then what you want to do is shorten the duration of your portfolio, because when interest rates go up, value goes down. If interest rates are anticipated to go down, then you'd want to increase the duration of your portfolio so that you would get a bigger price bump. Now, one of the things that I like about duration is that there's 3 things that impact duration. There's yield, time, and coupon. Let's take a scenario. Maybe there's a pension fund manager who has to have bonds in the portfolio, and they're lined up to match with pensions that they're going to pay in the future. So they cannot change the maturity structure of their portfolio. They cannot, because the actuaries have said no, you have to have an average maturity of X number of years. So they cannot, are you listening? They cannot change the maturity of their portfolio. And interest rates are expected to go up. Does that mean they're going to get hammered because the prices are going to fall? And the answer is no, not necessarily. Because remember, there are three things that impact duration. So if you can't change the maturity, you can still change the coupon rate. Maybe sell some low coupon bonds that are going to be more sensitive and buy some higher coupon bonds that would be less sensitive. Okay? Or focus on yield. Sell some of your AAA bonds, which are going to be more sensitive when interest rates change, and buy some A-rated bonds. So the point is that there's different things that you can do with duration. You don't always have to focus on maturity. You can also focus on coupon rates and yields. The last one is called the pure yield pickup. The pure yield pickup. And this is simply trading quality for yield. Okay, that is, how do you pick up yield? What if you were to trade a AAA rated bond for an A rated bond? You're going to pick up yield, because this might be yielding 4% because it's really safe. This might be yielding 5% because it's not as safe. And so that's all you're doing, is trading quality for yield. Right? So I know there's a lot here. I promise, you know, when the exam that I'm going to put together for you is not going to focus, especially on this chapter, on things that we didn't discuss. You know, I mean, not that I'm going to make sure that every word that I say is coming from your textbook, but I think I talked mostly about modified duration, Macaulay duration, what determines duration. We talked about convexity. We've also talked about immunization, negative convexity of callable bonds. So pretty thorough here. And then a couple of bond swaps. So that's going to do it. And I will be chatting with you soon.